Thanks everyone for joining, and hopefully my plan is not to bore everybody here with the slides. So we'll try to build some agentic workflows, but more importantly, what I wanted to talk in the next 30, 40 minutes is about agentic workflows. How do you essentially build, manage, and scale them out as you kind of grow into complexity? And to introduce myself, I'm the founder and CTO at Orkes. We are Before we get started, so Orkes essentially is a workflow engine. Came out of Netflix. Conductor, I was the original author, and Orkes is a cloud-hosted version of Conductor. So before we get started, right? This is an interesting thing. We see a lot about agents these days. Everybody's talking about agents, and agentic workflows are a big thing. So here's a very quick question for everybody here, right? What is an AI agent? Any thoughts? Yeah.
It's a task. Just the task, the default task, and then it may see a sentence.
Fair. Yeah.
Orchestration.
Yeah. If you think about an agent, right? Agent. The most important thing about an agent is that it is supposed to have an agency. It should be able to autonomously execute certain things, right? When you think about traditional workflows, it's very procedural, very deterministic. You know exactly what you're going to do. You have all the steps very well laid out and predefined. You can make very educated guesses or determine, how it's going to execute. The most important thing about agentic workflows are that, they are inherently non-deterministic in the sense that, they operate using a language model. So, the step that they might execute next, you can't really have very well-defined inputs and outputs that you can do kind of regression testing or unit testing. And if you think about agentic workflows, right, there are some core parts to it. I don't think this is very new here, but given an input, an agent essentially has kind of a planner. So, if you give a goal, it is able to kind of understand, what you are trying to do. It plans out, how it is going to achieve the goal, right? And to do that, it essentially leverages the memory system, some sort of, short-term, long-term, and a working memory. But more importantly, it has its tools. And what are the tools, right? Essentially, tools are, think about APIs. If you want to send an email, that's a tool. It could be workers, right? Maybe, processing some data. It could be also using agents as a way to collaborate and talk to, like essentially in a multi-agent system. Code tools are very well known today, right? And then it has essentially an executor that takes the plan, executes that, hopefully in a distributed environment in such a way that essentially you can monitor how it is progressing, and you can look at the results, outputs, and potentially embed humans as part of the entire agentic system, right? So when you want a feedback from the human, you are able to kind of get the feedback, maybe correct the course of action and continue forward, or maybe terminate the execution. And so that brings up another question, right? Why is it hard to scale agentic workflows in production, right? It's pretty easy to build out one, but if you want to start kind of putting into production, then there are few things that start to kind of pop up. One of them is the interactions can get really complex. Like if you think about a very simple agent, which has it can take either left or right, then maybe there are only two possible actions. But if you think about it, it starts to become more and more. If there are more and more control branches, then it can get really complex. And then comes how do you kind of debug that, monitor that if it took a particular decision as to to do certain things. You want to be able to reason about why it took a certain action, and being able to get insights into why some of the things happen becomes more and more important, right? And then usual stuff, observability, metrics. If you end up running an infinite loop and end up using all your token allowances overnight, who's keeping tabs on those things? And then things that we as engineers don't really love, but need one, is all about security, governance, and compliance. So this is where what I like to think about it is to have the agentic systems in production, you need a runtime environment, right? Essentially a runtime that can actually handle all of those things. I'm not going to kind of read through this, but things that we talked about in terms of, once you start putting your agents into production, you should be able to kind of have a runtime that takes care of all of these aspects of access control, governance, visibility, metrics, and all of those things. So this is where workflow engines becomes very important. And to be honest, this slide is a bit older. Today, I think, it's not something new when we think about workflows as a core platform for running agents. But agents and workflows kind of go hand in hand together. And if you think about workflow engines, they were designed for doing this kind of orchestration. Now, what you are saying is, let's bring in an AI agent that is essentially driving these workflows as opposed to humans or the programmers. But when you think about workflows, they are very well designed for this kind of operations, right? They often do the task orchestration. They can do parallel execution, decision-making process. They are designed to handle errors, recovery from the errors, and they provide all the necessary monitoring, control, everything that you kind of aspire, in a true agentic system. And as you kind of scale the agent-based architecture, right? Like, workflow engines also provide some of the very important things, right? Things like, for example, every task inside a workflow can be running in a distributed environment. So, that allows you to kind of scale how you are operating with language models. And that becomes even more important if you are running self-hosted models that you want to kind of run in a distributed environment. You could potentially build real-time feedback and monitoring loops. Oftentimes it has been said, right, that agents are nothing but LLM inside a loop. And then you can add humans inside the whole thing. And then feedback loops for more deterministic output, right? You can provide, let's say, instructions for an LLM to produce output that conforms to specific schemas or certain requirements. And if it fails, you can put a loop inside it to, keep retrying with a feedback loop until it kind of achieves or kind of gives up. But no, it allows you to essentially make it a little bit more deterministic from that angle. All right, so I'm going to skip this, and what I want to do is I want to kind of show essentially how do we kind of go around building an agent using Conductor. So as I mentioned, right, Conductor is an orchestration platform. So we'll start with something very simple. So we have all kind of seen various examples of deep research. So I thought of like building something pretty simple like that. So let's say, we want to build an agent that, given a goal, can go and do some research on a particular topic and, comes up with an output. And ideally, this runs for a longer period of time. Maybe this is running on a schedule, on a cron schedule, maybe doing a daily run. For example, let's say, what if I want to find the top 5 stocks for the day to trade and get some insights? Maybe I run this every day at midnight, or maybe a couple of hours before the market opens, and then use it to make my trading decisions. And then I can leverage language models like, for example, OpenAI GPT-4, right? To do the task planning. Maybe I can use Perplexity to do kind of the deep research, right? So what I've done is a very simple 2-3 step workflow. First step is to kind of, I'm leveraging essentially a GPT-4o model here that allows me to kind of research a particular topic and come up with a plan. And as you can see, right, I don't really have any prompts written down here, but rather I'm using a templating engine here. And then this plan is going to give me an array of JSON output that contains the entire plan that I'm going to run it inside a loop. And then I'm going to use the deep research model from Perplexity to kind of do a lot more real-time research on this one, right? So let's kind of dive a little bit deeper into the prompts. So this is my planner, and I have kept it very simple here. Of course, this can be modified to be a little bit more accurate and whatever not. But essentially, given a topic, I'm asking it to produce a JSON with a list of steps as plans. And I have tested this model with a few of the models. So I have associated those with the plans. So let's say if I see how this plan is going to work, I want to see is let's verify how this is going to work here. This is essentially the prompt management page that allows me to kind of write the prompts, test it out, make sure that they are well tested and works with the intended models. Yeah, so it looks like it is doing what it is supposed to do. So if I take one of the objectives, then I am going to put together another very, very simple prompt here that is designed to work with Perplexity. And I'm asking it to do some deep research, right? Now, let's say if I want to run this deep research engine or the thing, right? Like, here is it, right? And if I run this workflow, as you can see, right, like this is going to take a while. This is one of the reasons why you need also a distributed runtime environment or a workflow engine or a durable execution engine, because one, all of these calls are going to take few seconds, and depending upon how much you are paying for the throughput on the language models, this could take seconds to minutes. And what you want to do is you want to make sure that your state is persisted. This is the very first task here, but this could be fifth task. If that's the case, you want to make sure that if it fails, it continues from where it left off. So here it is, right? The first step is over. There are some tools and everything it has given. And then I'm going to kind of use Perplexity. In the interest of time, let's look at one of the completed executions or something that completed decently enough. I think I terminated this halfway down the line, but yeah, here it is, right? After a few iterations. So here it is, right? I asked it to gather some historical data, gave the tools and whatever not. And here is the output. And I can collect this, put together a simple UI using maybe Cursor, maybe Bolt, any of those, AI coding or site generator tools. And there you go, right? And this can keep running. You can decide how long this loop to run. Maybe you can have more nested loops. I can add one more task that takes the output of this task. And then, does further refinement. I can probably put in some more, React-like prompts to do some more kind of critical thinking on it and do it, right? And there go, right? Like this is my essentially a deep research engine that does kind of a lot more. And I can essentially use a committee-based approach as well, right? Like I can probably do instead of a single task here, one of the things that I can do here is I can run them in parallel, right? I can maybe use a text complete task with Perplexity, maybe with GPT, and then get multiple models to kind of think about it, use another model. So whatever you can think of, you can essentially build and design here, right? So that's a very, very simple example of a deep research engine that you can put together using Conductor very quickly. Let's take a look at a slightly more complex example. If I were to, let's say, build something that can do a little bit more complex things, right? So let's think about a planner agent, right? That if you give a set of tools, a goal, and some context, is able to plan and execute, right? Now we are talking about something that is a little bit more than just executing a series of steps in a loop, but rather actually coming up with a plan. And when you think about a plan, right, we are talking about decision-making aspect of it, probably doing some loops and whatever not. So let's say I have built an agent planner. So, we have a task called an agent planner here. What it does is, it takes a few things, a well-tested model that is supported, more importantly, a goal, some context, and tools, right? So what I'm doing here is that, let's say I'm building a very simple customer service agent, right? And it can essentially look up my CRM to get the top N customers, send an email or SMS to those customers based on, whatever I'm trying to do, right? So maybe I might be scheduling this to run at least once a month to get the top 5 customers, send them a thank you note saying, thank you for being a loyal customers, maybe here is some coupons and whatever not, right? Depending upon what you are trying to do. So let's say if we execute in a very, very simple one, let's say I want to say, get me top 5 customers, right? And the interest of time, again, let's, as you can see, right, like what I'm doing is, yeah, here is right. Here's my input saying, give me top 5 customers. And what it does is, it comes up with a plan. And I am essentially fitting it to another task that can actually execute this entire thing into another execution space. So let's look at it, right? What it is trying to do. Here it is, right? We gave a task called top 5 customers. It schedules the task. Of course, I don't have anything running here, so it timed out. But if you look at the inputs, it gives n equal to 5. Assuming that I have this service running, it's going to go and find the top 5 customers. But let's look at a little bit more complex examples. Yeah. So here, what we are doing is here, my input is a bit more complex. I I want to find top 5 customers in US, not just top 5 customers, right? So, you would want to find the customers and then filter them by the country, which means, you are doing a little bit more. So here, if you look at the plan it created is, you get the top 5 customers. For every customers, just check if the country code is US or not. Now the question comes is like, how do you know, for this customer output, what is the field that determines what's the country code? So the way to do that is like when you look at the input, what it does is it also identifies the schemas that are maintained in the system. So, there is the entire notion of maintaining the schemas. So I have a customer schema and I know that, there is a field called email address, there is a country code, and then it can use it to do those things. So now, you can essentially build a lot more complex agents that are not just, a loop with a single task, but rather a lot more complex decision-making process. You can put them to run on a schedule, use it to send out an email, but that gets you a lot more powerful systems. Now let's look at a little bit more real world example use case, right? So, we have all been through this, which is interviews. So here is a more complex and a slightly more real world example of an automated agent that can be used to conduct very contextual, language specific interviews when you are screening candidates, right? Oftentimes what you end up doing is either you have to subscribe to a tooling that charges you, whatever thousands of dollars a month, or you are essentially have a predetermined list of questions, or you send them a lead code or HackerRank assignments. But what if you could make it a little bit more agentic, right? Where just like a human, you are assessing a candidate based on the language that you are interviewing them or a particular concept like distributed systems, databases, or whatever not. And then based on their answers, you can refine your questions and everything, right? So if you think about it, this is how we would do, right, as humans. And this is exactly how the workflow is modeled. You are getting the initial set of questions. This is assigned to a human. So which means that it goes to someone maybe in the HR or somebody on the software engineering team who determines based on the candidate profile, what kind of questions to ask and, can set the preference. So for example, in this case, the candidate name is Viren and language is Python, which means this interview is going to be focused on conducting questions about Python. There is some data processing here. And then there is the initial question. It talks about the initial question. Then it waits for the answer from the candidate. So let's say, here is the very first question that was asked. It asked about finding a unique element in an array, right? And the answer was what? What did the candidate answer? Said, I don't know. All right. So what happens when you ask a candidate a question to find unique set of items from a list? You probably want to ask a more simpler question, right? You don't want to go and ask how to invert a binary tree. So here is where another agent comes. So, this feeds into another evaluator prompt that looks at the instructions, questions, answers, the historical stuff. I mean, whatever is the history of, all the interview questions and answers, and essentially now makes a decision. So here's our decision tree, right? Either you can simplify the answer, you can give it a hint. If the candidate got almost there, then maybe you can give a hint and ask them the same question again. Or you can essentially, call it done, saying, the interview is done because, I asked all the questions that I asked. Or you can maybe, go to an error condition and maybe terminate the interview. And then finally, what you are going to do is, you are going to kind of send out a thank you email. So, you construct the email text, send out a thank you email. And in parallel, essentially, you create a Google Doc. So here is a simple a worker that essentially stores the transcripts into Google Doc and shares it out on a Slack channel. And that's basically the entire agentic workflow loop, right? You can start using this and, it's probably going to be as good as human, but it saves a ton of time in terms of, pre-screening the candidates. So yeah, as you can see, right, orchestration is definitely the key when it comes to building the agentic systems. And these are all built on top of Conductor, right? Conductor essentially is a distributed agentic workflow engine. It does all of those things and a lot more. It can do microservices, orchestration, APIs, regular plain old workflows, integrations, and so forth. And essentially the way Conductor works is, Conductor is a server, is an orchestrator / router, whatever you call it. But what it does is that it takes a plan or the DAG that you want to kind of orchestrate. And DAG is a combination of your operators, similar to your programming language constructs, right? Loops, decisions, fork joins, and whatever not. And the steps are essentially your tasks. This can be long-running asynchronous tasks or synchronous API executions. And depending upon your use case, you can trade off latency versus durability there. And more importantly, it allows you to put humans in the loop, which is where a lot of AI use cases that we are seeing are being used where in the end, once the plan is created, the plan is reviewed by the human. So they can look at the diagram and say if this makes sense or not, and either give a feedback to correct it or go and execute those things. And workers essentially are the very lightweight SDK-based code written in pretty much any language, Java, Python, Golang, C#, TypeScript. And they are constantly polling the server to do the work. And again, Conductor SDKs are polyglot. So, you can pretty much use any language and it's pretty straightforward. You can take any function written in Go, Python, Java, annotate them as a worker. And that's pretty much it. It's good to go after that. They are all open source as well. So, all right. So in the interest of time, we're just going to skip through all of these things. So how do you get started, right? So again, Conductor is open source. We built Conductor at Netflix. I know there is a next meetup coming up next week at Netflix. This is where we built Conductor. It was open sourced, and then essentially 3 years ago we took Conductor open source, and Orkes was built to manage the cloud-hosted version of Conductor. You can check out Conductor repo at Conductor OSS on GitHub. And definitely, if you want to be part of the community, more than welcome there. There is a link to the Slack channel there. Feel free to join. It's pretty widely used, of course, at Netflix and many other companies. So I'm going to skip through all of those things. But yeah, if you want to get started, here are some of the links and QR codes. You can feel free to scan it out. If you want to try out any of the examples that I just showed here, you can go to developer.orkescloud.com. That's essentially the cloud-hosted version of Conductor, so that you don't have to set up anything locally and you can start using it. It's free. We don't really charge for it. And there are some code samples here. We continue to add more and more. That the link is given there.
Hi, so we'll take questions now. Just raise your hand and I'll bring the mic to you. Make it easier.
I was wondering if you could comment on OpenAI's deep research. Would you call that an agent? Or if no, how would you compare that to a platform like yours?
I think that's also an agent, right? Behind the scenes, essentially, it's doing very similar, or if not the same thing. The key difference is, it's pretty much into their ecosystem versus, typically, if you want to build your own, you also want to be able to connect to your data and systems and whatever not. So that's the flexible part of it. Yeah.
You said that you don't really charge for this, but on your site, it says request a demo. Do you have a plan to, in the future, start monetizing this?
Sorry, I didn't get your question.
So the Orkes thing that you're working on,
yeah.
Right now it's free. Do you have a plan to start monetizing it in the future?
So the developer account is free, but we definitely have a cloud version. We have customers who are using this, and of course, they are paying for it. Yeah.
Actually, it's a two-part question. If agents are so capable, why do we need multi-agents? And so does that mean an agent has a limit in terms of its performance that you require multi? And what is that limit? And then the second question is, you say, oh, this is just as good as human, we just program as human, et cetera. Does it overcome the traditional problems that humans have, like collective action, transaction costs in terms of workers, right? Is that what's happening here in some sense, where if you have these agents, they overcome the traditional obstacles to organizing or the growth of the firm or something like that? I don't know if you know economics or anything like that.
I mean, I can't really comment on the economics part. That's not my area of expertise, to be honest. But I mean, the way to think about, at least the way my kind of frame of reference there is, it allows you to kind of be more productive, right? Just like, when we think about the co-pilots, a lot of times when I want to write my unit test or look at, some of the implement some of the algorithms, I just use the co-pilots to, get it done. Not that I can't do it, just that if somebody can do it in seconds, why should I spend minutes to doing it? So it's about productivity as well, right? And I can focus on more important things that matters and solving the business problem rather than solving the problems that has probably little business value.
Quick question. Two questions, actually. How does this compare with BizTalk? Something like BizTalk, which was an orchestration tool a decade ago.
Yeah.
And then how does it also compare with Amazon's orchestration tools?
Yeah. So BizTalk and all, like if you think about it, right, there is an entire kind of generation and the era of workflow engines. BizTalk is one of them. Then you have IBM's and Oracle. All of them had one. And I think the primary kind of motivation there was that, hey, let's build a workflow engine that will allow people who are the owners of the process, like the business analysts or the process owners, to be able to model a business process. And as a developer, you will take that model business process and kind of implement it, right? Reality was that, like, they would just give it to the developers to do everything. So the way we approached the problem at Netflix was that in the end, if the developers are the one building everything, we should build something that works for us. And the way we understand things is how we program things, right? So fundamental shift is it's a developer focused product rather than end user, and end users get the visibility, but they don't have to think about, like, how to do those things. They can state their goals and developers can focus. So that's the one area. Second question that you mentioned was like, so, when you think about step function on AWS, they came out of the similar thing, right? That let's make it more developer friendly. The key difference is when you think about step functions, and Microsoft now has things like durable functions on Azure and so forth, they are very much rooted into the cloud native or the cloud specific ecosystem. And today, like most of the enterprise have a very clear hybrid cloud or multi-cloud strategy. So this is where, things like Conductor plays an important role, which is agnostic to the cloud. You can run on your laptop to on-prem to multi-cloud and whatever not. So otherwise it solves similar problems, but in a more cloud agnostic way.
Over here. Over here. What has been some of the more surprising or impactful use cases that you've seen customers use Conductor? And I guess like the next part is like, what do you foresee on the horizon where, many companies or customers may not be paying attention to, where Conductor could be like highly impactful? Yeah.
Most surprising use case. I think the most surprising use case for Conductor that I have come across is running Conductor on an X-ray machine by, I believe, GE Healthcare. So when you take an X-ray, it has to go through a whole bunch of decision process, and they embed a very lightweight version of Conductor inside the machine. That was not it was intended for, but they are using it and they seem to be happy. So that's the most surprising use case. Everything else could have been thought about, but that was never something that I could think of. I think the second question was, where else can it be used, right? So I think the most underrated thing is that, like, when you are building applications, right? Like, let's say, even if you are building through microservices, event-driven systems, or even when you think about monoliths, the most underrated aspect of every application development is state management. There is always a state that you have to manage. And whether you know it or not, don't understand or not, you are always building mini workflow engines which are very specific to your use case, right? Order management, booking systems, anything. There's always a steps, and then you have to persist the state and manage and build everything around it. And that's where things like Conductor and workflow engines can play a very powerful role, because they take away all this burden of managing the state from you, and then you can focus on focusing on the core business aspect. Yeah.
We got time for one more question.
So I have seen a lot of agents retrieving data from websites and so on. Does it come also with a tool set where it writes back to, let's say, dynamic forms which are rendered dynamically on the website? Let's say using React, it's not like a static website. Are you also providing some tools for this?
So what we do is that when you embed a human task, you can provide the JSON UI schema, and we have a very basic form renderer. But oftentimes the feedback that we have gotten from the users and the customers is that the way they think about the forms is, they want it to be something that they drive, how it is presented, how it is embedded, UX and everything. So they would rather keep that under their control rather than being done by a platform.
Well, thank you very much for your presentation and for your time.